Hey, hello, and welcome to the show. I was just checking audio meters for a moment. I thought, uh-oh, is that not working? It's on. Yay. Hey, it's me, John Park, and this is my workshop. Thanks for joining me. It's great to have everyone here. I am excited about today's show. I got some cool stuff to play around with and show. And I want to thank people for stopping by in the chat. I could see we've got a bunch of people over in our YouTube chat. Hello. Hi, Creative Indonesia, Luis Rodriguez, Dave Odessa, Gary T, Johnny Bergdahl. Welcome, welcome. And then also we have our Discord chat. So if you're somewhere, hey, that's not the Discord chat. What did I do? What did I break? Ooh, hold on. Let me fix that thing. I bet I'll break another thing when I fix this. But hold on, we can adapt. Hold on. Where'd you go, Discord? There. Huh? Oh, yeah, there's the Discord. How did I break that? That's interesting. And if you want to, you can find our Discord just by heading over to adafru.it. That's ADARFU.it. I guess we're in Italy. No, that's our URL shortener. adafru.it/discord. And that will give you an instant invite. Head over to our server. That's this thing right here. And then you can look for that one right there. That is the channel you want, the live broadcast chat channel. That's the one that we're on during the shows. And as you can see here, we have a ton of channels. So if you want to go over to the Help With section, you can find help with CircuitPython, help with 3D printing, Adafruit.io, Arduino, audio, Git, hardware design, and on and on and on. And a bunch of other interesting topics. CircuitPython dev is where the CircuitPython dev people hang out a lot. C. Grover waves with a sandwich. I just had a sandwich for lunch, so no thank you. I'll have to stop right there. Oh my gosh, now everyone's overloading it with sandwiches. I might need a second sandwich. I've got big plans for some tomato soup and grilled cheese this weekend, especially because it's going to start raining again in Southern California, so that becomes good grilled cheese weather. What else have we got happening here today? Let's see. I have a coupon code for you all. If you want to head to the Adafruit store, hey look, I've got rain on the mind. Umbrella is your coupon code. That'll get you 10% off in the store. You fill up your cart with stuff. This won't work on software or gift certificates or subscriptions, but it will work on actual things, of which we've got a lot. So throw some cool things in your cart, and then on the way out, look for the coupon code field and just type in umbrella. And that will get you 10% off on your order today. Let me, let's see. Oh, good. I didn't break this, so that's good. So this is the store. If you want to head over here, just jump on over into the Adafruit store. You can see we've got a little new products section there showing up here. Some cool new black relegendable plastic keycaps for MX key switches. You can pop the little clear tops off and put labels or stickers or other things in and drop them back down so you can make custom layouts. And then head on over to the new products link. That'll show you all the latest stuff. Excuse me, you may want to set that little notify me and type in your email address if you're looking for the new Metro M7. That's the new hot Arduino shaped board that we have using the M7 chip. It's in alpha right now, so it has some stuff that works, some that doesn't. It's super, super fast. It's going to be a really interesting one. That's not in stock right now, and we don't do any rain checks. You can't apply this discount code, but we've got a lot of discount codes, at least 2 or 3 every week. And you can look for some other cool, fun, interesting new things here, or just go back into the products, featured products, or if you expand out the shop here a little, you can go into these categories, view all. Go find some stuff. It's how we make our money. It's how all the content we produce gets produced by selling you some good stuff. We're not shy about saying that. So go get yourself some stuff, and as a little thank you, get yourself 10% off with the coupon code UMBRELLA. Today, it is good until about midnight Eastern Standard Time, or Daylight Time. I never remember which one we're in. I should learn those. Let's see, what else is happening? We've got the product pick show. Speaking of products, new products, on Tuesdays, I have a product pick of the week. Happens right at this time, same time, 4 o'clock Eastern. 1 o'clock Pacific. And on the show, I like to pick something new in the store, or sometimes an oldie but goodie, give you a 50% off discount in this case. It's not always that much, but often it is, especially if it's an Adafruit product, where, as you can guess, our margins are higher than reselling other people's stuff. We like to try to give you the 50% off. This week it was this really cool display. Here is a little excerpt. It is the 1.8-inch TFT display breakout with micro SD and iSpy. Having that little flip connector there so that you can put a ribbon cable in means your wiring is so much neater. You can see I've got one of our 1.8-inch TFT displays with the iSpy connected up to iSpy breakout, and then that's running to an itsy bitsy M4. This is a really cute game that's on the main page of Make Code Arcade that is about some mice performing Shakespeare, and you are the spot operator, and you got to keep the spotlight on the actor who is currently delivering lines, which is adorable and amazing, and I love it. That's my product pick. It is the 1.8-inch TFT display breakout with micro SD and iSpy. Whoa, hey, that was just going to go ahead and loop endlessly. There's a button I have to hit when I bring a new movie in. I forgot on that one. So let's see, what else is going on? First of all, over in the chat, we've got people talking about their weather. So it's snowing in a bunch of the places that we've got viewers dialing in from. Andy Calloway and Dave Bergdahl said they've got some snow. Mike P says the LED strips are mesmerizing in the background. Yeah, aren't these great? These are the Scorpio board. So this is a RP2040 Feather that has. Lift this. Oh no, that's all plugged in. I can't. Yeah, the cable's a little short to my power there. But yeah, that is a Scorpio Feather that's running. What do I have here? 8. 1, 2, 3, 4, 5, 6, 7, 8 NeoPixel strips, all on their own channels. The lighting blows it out a bit, but I think, what am I running? I don't even remember what I'm running on there. I think that's an Arduino sketch that I adapted, but I can't even remember. Whatever it was when I did the show, that was on Product Pick of the Week a couple months ago. That was what I built there. Let's see, so what else do we have? Oh, hey, here's a cool one. Let me get set up for a little CircuitPython parsec. Here we go. Yeah, let me turn that mic on. And I've got a couple windows, so I want to get those set up. Here we go. What I wanted to show you today on the CircuitPython parsec is how to use the ANSI escape codes inside of CircuitPython. So this is a library from the community bundle, which I've put the URL up at the top there if you can see that. You can get it, however, just by, if you have circup installed, you can type circup install ANSI, ANSI, underscore escape underscore code. That will install the library on the current CircuitPython board that you have plugged in. The way that you use this, and the reason you use this, is to do things such as coloring your text inside of the serial REPL output, just like any kind of a traditional terminal. So what you can see here is that I'm using it to color code some of the events that I'm debugging. So as I press keys on my keypad here, you can see I get this little background color of cyan. When I release a key, I'm creating kind of a blue or purple color on the text, except for this one, which shows up as pink. So imagine you're doing some complex debugging. It can be nice to be able to color code things using the ANSI escape codes. So the way this works, I have imported ANSI escape code as terminal, and then when I go to print, I'm using the same print command as usual, but you can see right here, here's an example. When I press a key down, I'm saying print and then terminal.ANSI colors bold, so I'm bolding the type. Terminal ANSI colors BG, background, is cyan, that's how I'm getting that light blue color. And then the things I wanted to print, in this case, the number of the key that I'm pressing. And then I'm resetting that so that it doesn't just leave the rest of all of the things that I do in the terminal in this bolded and cyan background. Now, when I release, I'm doing a similar sort of thing. I'm saying, when I release a key, we're gonna, if the key is this 0 key, change the color of the foreground to pink, ANSIcolor.fg.pink, and then I'm resetting that. On the other ones, I'm setting those to blue, which actually is kind of showing up purplish in my terminal. So there are other things that you can do with this, including moving the cursor around, strike through, invisible text, a lot of interesting terminal effects that you can get using this. And that is how you can use ANSI escape codes inside of CircuitPython. And that is your CircuitPython parsec. And I wanted to show, since there's a GitHub page for this that you might want to take a look at. Let me bring back my Chrome capture window here. You can see this is S-Lite. S-Lite is the user, github.com/S-Lite. CircuitPython ANSI escape code. So here is the documentation for this, as well as the code. There are a couple of different examples. And you can look here, if you go and look at the library itself, this is the .py version of the library. You can see here some of the options that you get: reset, bold, disable, underline, reverse, strike through, and invisible. Here are the inside of the foreground color class. Here are the colors that you can use. Here are the background colors and more. Actually, these are. I grabbed the wrong list. Those were commented out there, as well as some of the cursor movement things that you can do. So really nice, useful for debugging. I often do things like make things uppercase or lowercase or indent them in, just so that when I'm debugging complex stuff, I can find output, especially things that have to do with keys. If you're building keyboards, MIDI keyboards, keypads, these kinds of things, you have a lot of interaction where you're looking in your terminal view there to see what's going on. So I think this is going to be super useful, and I hope you find it useful too. David Essa asks, JP, any chance you're streaming at 1080p? It would make text easier to read. Thanks for asking that, Dave. I may. I used to, and then I started to run into bandwidth issues. I think, knock wood, I'm going to go and curse it now. Knock wood, my bandwidth is a lot better now, and I have about 20 megabits per second up, which I think means I could potentially get away with 1080p without too many problems. So I agree, yeah, text would be a lot easier to read on 1080p. So I will consider that. I could probably also work to make some of this text bigger in the current 720p that I'm broadcasting at. All right, so I've got a few different things I want to talk about today. I've got some updates on projects. I've got some upcoming projects. I've got some show and tells that I want to do, some cool stuff. So let me start with Learn Guides. This is, oh yeah, that is where I broke that. How did I, let me add one, let me add a layer to this of, let's see, is this going to be it? Oh yeah, so I'll make a fresh screen capture. 1 second. This is going to give us a black hole for a moment. And here is, what am I looking for? That. Okay. So this is the Learn Guide that I just put out for my Cybercat MIDI keyboard that I've been working on. I won't go through it step by step, but I wanted to just point out some of the highlights on here, and I'd be curious if anyone goes through either this project or a similar one of converting something that has a matrix keyboard into being read on your microcontroller. If you have any ideas, thoughts, questions, problems, issues you come up with. This one was fairly straightforward. I still listed it as an advanced guide because you're really in there digging around a decent amount to get things connected. But the key thing here is if we jump into this build section, we've got our disassembly. Here are the innards here, and I showed these on the show. I just wanted to point out, if you look at these, one of the interesting things is that this circuit board that is at the bottom here, which is the keyboard, where you see that kind of Cheshire Cat smile frame there, this is a input pad, and it's kind of a hub. So there is a 6 by 8 or 8 by 6 matrix that is ultimately what all of the buttons, switches, oh, you can't see it. I didn't push it over. Ah, thank you. Ha. Thanks for Mike P. and Andy Calloway mentioning that I wasn't showing that. There was since I added something, it doesn't automatically push to my output. Okay, we didn't miss much of anything. So here is, I'll back up just a step. Let's see. So here is the Learn Guide for the Cybercat MIDI keyboard. So this is another one of my Meowsic keyboards. This case I painted it black so that we could distinguish it from the other one, which was orange. The build section here, show you how to disassemble it, and then in discussing, whoops, not that photo, in discussing this right here, these innards, as I called them, what you'll see is there is this key matrix, and it's a series of little contact pads that get pressed by the keys. This set of matrixed switches runs to originally the main board of the keyboard over these 2 ribbon cables here. And tell me, can you see my cursor? I think, yeah, you think you can see my cursor there. However, this PCB that's the keyboard is actually also kind of just acting like a hub for connecting up other things into that matrix. So you'll see here we have a set of 5 buttons in this PCB that's off to the side. That is originally the, I think those are the rhythm section things, so like the different drum patterns are on those. And then over on the other side, similar sort of thing, we have, sorry, these are, okay, on this darker PCB that you see here, these are the 5 rhythm, as well as the record and play buttons. These are the 5 patches, so the different sounds, the cat sound, the piano sound, the organ, whatever else there was. These run, this one here, as well as whatever this little button is off to the side. I think that was like the cat face button. This is the nose button. This is the little treble clef button. Those all run not to the main board, just for routing purposes. They ran them, the engineers on the original, this is the original, this is disassembled, but I haven't desoldered and resoldered stuff yet. It almost all runs into here and then to the main board. You can see we've got 2 ribbon cables running from here. That's a hub for almost everything. And then there's this one block here, the record, play, and rhythm buttons. Those run over a set of ribbon cables. These are actually all overlapping. So the ribbon cable coming from this record button section, those are not unique pins. Actually, those are pins that are also shared by other stuff. So it's the matrix combination of things, the 6x8 matrix, that allows the software running on the original microcontroller there, or in my case on my KB2040, to distinguish the different button presses. So all of that stuff is part of this matrix. And so what we do is desolder those things and wire them back up. So here I've got, here's a close-up of the PCB. So there it says jack 3, jack 2, and then they don't label this one. Those are the sets of ribbon cables coming in from the different buttons. And then here I've got just a little diagram to show you. These are the 2 you're going to desolder in pink here, these 2 rows, which will then run to the KB2040. So we're leaving a bunch of buttons connected up to this hub-like PCB so that we don't have to rewire any of that. Those are all shared on these 6x8 cables. And so here's a image of resoldering. I just happened to have some of that nice silicone insulated, flexible ribbon wire that we sell. This is, I think, the 28 gauge stuff. It's just really nice. I didn't know, I kind of needed more length than those original stiff cables did, so I did away with those entirely. And they don't need to be connected to the original board, so that was, they were coming off anyway. And here you can see on the back side of the original PCB, I've got just the necessary 5 connections that allow us to use the buttons that are on that board. Those are the arrow, the 2 sets of arrow buttons are on those. Here's a little fritzing diagram as well as a schematic I did in fritzing, so you can tell what's connected to what, and then build that circuit onto a perma-proto. A little difficult to look at, but hopefully along with the schematic and the fritzing diagram, it'll be clear what's what. Part of this is that we're running some resistors and a stereo connector off. If you want to use classic MIDI, you can omit that if you don't want to. And I'm also running the original on-off switch. There was a slide switch, single pole, dual throw slide switch. I'm just using 2 legs of that to run to the enable and ground, so that we, or rather the reset and ground, yeah, so we can flip that real quick if you need to actually go to the bootloader on the board. That'll allow you to reset the board without having to add another button. So, so this is what it looks like after the addition. So you can see some of these are still connected exactly as they were, running through that hub to our new, those 2 black cables, and then the 5 pins off of the main board to there. So hopefully that is clear for people if they have questions about this. And then there was the addition of the ice cream cone, a little bit about painting. One thing, I mentioned this last night, one thing that's not in the guide as far as the painting goes, and I might add a little addendum, is that I had primed and painted the eyes. So I masked off, primed and painted the eyes green. Then I painted over them and everything with black. For the photos, I left it that way, but then after I'd finished the guide, I went in just with an X-Acto knife and scraped away the layers of black paint to get down to the green. I had done like 4 or 5 coats of green just so I wouldn't scrape through it, because I knew I was planning on pulling that off. It was just difficult to mask this. I might have, if I had known exactly what I was going to do, I could have probably just cut that out of tape and masked it like that before I painted black, but I wasn't sure if I was going to do the whole eye as green or not. So anyway, that was a little extra there. So the Cybercat looks a little different now than in that set of photos in the guide, so I might update that. And assembly, and then final assembly there. And then I've got a little usage guide here of what those different buttons do. There's a video here. It doesn't want to show up right now, but there's a video here of it in action, and I also demoed it a little bit last night. I had a mishap trying to use the ice cream cone for MIDI CC last night. I'll bring it back on show and tell next week and show that in action. It works really well, but I had hit a button that made it not send any CC that my synthesizer was going to pay attention to. And Phil was asking last night about the paint jobs on this. One open question is what people can recommend if there's any kid-safe paints out there. This is not, and I made a bad suggestion of maybe Plastidip, but yeah, that stuff peels off, so kids will just eat it like fruit leather probably. But Phil was asking about this black paint job. I used a Rust-Oleum flat protective enamel paint. It's got a nice flat matte finish to it. This stuff is what all the black is. Where you see it shiny, I used the same paint, but I added some clear coat. So that's kind of a nice, gives you a nice look without needing to use two different paints. So just the one black paint, and then some of the stuff I hit, like the black keys, the nose, and the little switch there. I used the clear coat, which was just something I had on hand. It was, where'd it go? This Krylon Crystal Clear, which actually got an art supply store a few years ago, so the picture on it is of paintbrushes, but it seems to work just fine here in this use as well. Let me set these here. So that is our Cybercat, and it's fun. It's actually a really customizable MIDI keyboard. I have a couple of other little MIDI keyboards that do different things, but this one is pretty unique. The fact that it has the accelerometer and the ice cream cone, it has a bunch of buttons that do very specific things that I've programmed in it. Having a hold button that just doesn't release the keys until I want it to is kind of nice. Some Nice says this is the car version of Murdered Out. Yeah, people with their murdered out cars. This is the Murdered Out Meowsic. Well, maybe I should have called it that. I like that one. Okay, so go make yourself a MIDI keyboard out of a Meowsic or out of something else. A lot of fun. KB2040 made it easy. So next up, I wanted to do some show and tell stuff. Let me jump over here to the workbench. So you can see, actually, before I do that, yeah, we'll start with this one. You can see right here, let's go to that one. So right here, this is what I was showing during CircuitPython parsec. This is very similar to last week's. I think I showed this one last week. But I'm going to adjust this exposure so you can see it. The big difference here, I'll go ahead and unplug this one, is that this is the revised PCB. So I had said last week I made some errors, a lot of them, and you can see here I've bodged tiny wires to connect ground planes because I had islanded a bunch of stuff. There was no ground going to a bunch of things. And I also plated in I made the footprint in fritzing. My fritzing part did not drill out these holes, which means there was a potential to short out these. Let me see how close I can get. So these holes here that the neopixels, reverse mount neopixels drop down into, they're very, hold on, get exposure up. They're very much in danger of being shorted to that ring there. So these should not be plated. I made a mistake in the part definition. There you can see some of the little bodges that I did to move ground around places that I just made mistakes on. So on the new one, that's not the case. So I was able to, oh yeah, so here's the old one. There's the original one there. And you can see on these, I somewhat accidentally, somewhat for reasons of fritzing, ended up putting my silk screen on the front, and then on the back I just threw the word ground to show me which pin of the NeoPixels was going to be the ground pin there. But there's the plating. So here's the new version. So I made three changes. First of all, I correctly grounded the grounds. So every one of these little sort of plus-shaped contacts for ground are actually properly running to the ground plane in the back here, and none of it's islanded. So that was a plus to just do that right. Second thing you can see is that the holes are not plated anymore. And this was actually the difference between, I think, saying in the SVG file, whether you generate it in Illustrator or Inkscape, you probably should check these out in your text editor. I did these SVGs out of Illustrator, and even though I said, I think I gave these holes a stroke of 0, it exported the SVG as saying stroke of none, and that didn't work. You actually had to have like 0.0, and then it doesn't plate these in the way that the G code gets generated in fritzing. So now I know, and I'll put this into a guide so that anyone else who's making any footprints in fritzing will see that. And then the other thing I did was, I mentioned last week, fritzing does not like trying to make a single part that has both through hole, which is these two pins here for the switch, and surface mount pads, like these right here. It just doesn't like that. It ends up causing problems with turning holes into connections that shouldn't be. It kind of put like a connection at the center that just doesn't even really exist. So it made it hard to route stuff in the PCB. And by the way, I shouldn't be 100% sure that this is fritzing's problem. This is the first time I did this complex of a footprint, so I could have been doing things wrong. But I was talking with a very helpful expert users in the fritzing forum, and they didn't think that fritzing probably would love this dual through hole and SMD part. So I turned these into two separate parts. And so now there is a reverse mount NeoPixel part that has a silk screen that allowed me to match it perfectly with the chalk switch part. And I decided to mount it on the front instead of on the back. So it's actually not even really reverse mount, but these little pixels sit down into the hole just fine, and I was able to still put my switch on top of them. I don't recommend this because now I can't ever service these while the switch is in the way, so it is nice to have the surface mount part on the back and the through hole on the front. But I gave up on trying to make that work in fritzing. Good news is it all works though, so here's the final result here. If I pull off a couple switches, or keycaps rather. And let me adjust that focus a little bit. You can see there I've got the switch, and if you look right here, shining through is the NeoPixel. So that's the NeoPixel facing through there. If I go ahead and give this power, see that line up. Very bright. NeoPixel doing its thing. You can see them from the backside pretty well. Boop, boop, boop. So that's them. And I'm going to continue on now with the design of a case for this. I am considering something sort of modular to have a reasonable neighbor case that you could use for Stemma QT stuff. So we've got the Stemma QT connector here, so it might be neat to make a modular system where I can snap together, not two keyboards that would be cool too. I don't think I'm going to do that. But just a second or a second and a third thing that are Stemma QT hexes that could give you a screen and a knob and other buttons. That might be fun. But I'll start out with this, just with this little macro pad, this one right now. The code I was showing last week is sending some neat isomorphic MIDI key stuff to a synthesizer. Yeah, and some CAD talk over in our Discord there. Eagle, great one to learn. I've used that a bit over the years, and then I forget it every few months and have to relearn it because I don't use it often enough. KiCad, or KiCad, however it's pronounced, I will, I think, take a stab at learning that and moving over to that. Because I can see that as much as I love fritzing, and it is cool that it can really actually do circuit boards, it is a little underpowered from the part building standpoint. And now I do love that it's got the breadboard view, the schematic, and the PCB view, so it's perfect for learning. But it's you know, I don't think it's anyone's arguing that it's as powerful as something like Eagle or KiCad or Onshape, other ones that people are suggesting there. So that's the hex keypad. I'll be working on that, and then I'll be actually collaborating with Noe on that. I think he's going to do a final version of the 3D design, as well as some sexy 3D printing videos and final videos, hopefully. So we'll get some good looking stuff from that. And let's see. Oh yeah, and Bill said the rules checks are great for catching issues before you send it to the PCB fab shop. Okay, the fact that I have all of these bodges on this one, again, partly my fault. I just wasn't paying attention. It was late at night. I ran rules checks, but I had to ignore some because it was drawing rat's nest lines for ground even when I had a ground plane, and so I started just ignoring any black rat's nest lines, and clearly it was probably trying to tell me, hey, you got some stuff here that's really not connected to ground. So, you know, again, I'm not an expert user in fritzing, so it's very likely my fault, but if I have any excuse, it's that I had stopped paying attention to the software's efforts at correcting me before I sent things off to the fab shop. These, by the way, if you're curious, I've been doing these at JLC PCB for five of them for about $25 shipped. It's like $3 for them to do the fab, and then $18 to ship it DHL in a few days. So I've been getting these back in, what, a week's time or a little less. It's pretty amazing. So not a bad price to do low volume prototype. It's fastest and cheapest if you do a green PCB. You can add a couple days to it if you go for some of the other colors, and then you can make it more expensive if you start adding fancier features. But these have been working out pretty well. All right, so that's what's going on with the hex pads. I wanted to do actually some other show and tell. Let me swap over to this view here, and I'll have to focus up that camera. I got together with my good friend Todd Kurt a few days ago, and Todd gave me some cool prototypes and PCBs he's been working on. I won't go through all of these, but I did want to show this one because this is, I think, one he is selling on or will be selling on his Tindy store. This is the PyTouch Grid. And this one is actually in a little 3D printed case that has a nice little angled set of feet on it there. Let me give this one some USB power. This is one Todd had posted up on his social media, and it is a capacitive touch PCB. There we go. Sorry, dropping things over here. Uh-oh, Todd, does it work? This will be embarrassing. I didn't test this. Are you actually? Oh, it's not plugged in. It needs electricity. Oh, that's the wrong. Okay. So this is a capacitive touch PCB with reverse mount NeoPixels under it, and the most addictive little fade gradient sketch going on there. Let me see, can I lower the exposure on this camera? Ooh, so he has this one programmed as MIDI output, I believe. So it's a MIDI keyboard, and he's got hardware MIDI out there. You can't see that; it's too dark. Hardware MIDI output there, and USB MIDI out. There's also room for a little screen there. You can't see that because I made it so dark. But that's the main attraction right there, right? We don't need sound. We just want to touch the pretty NeoPixels. So you can play it like a keyboard. And Todd said that he had originally been thinking about doing like a little tiny touch keyboard, but as a MIDI keyboard, especially if you set it up as an isomorphic grid so that it can't play any bad notes, you don't have to worry about if your finger is big and hitting too many of these at once. It's all going to sound good. But I love that. It's gorgeous. I may just plug that in and leave that nearby to play around with the colors, the pretty colors. So thanks, Todd. If you're in the chat right now, if you could post up something about it, or if anyone can go and find it. I believe he has a posting up on his GitHub, and there should be some of these headed to Todd's Tindy store at some point. I think this is early beta. So I'll show some of the other stuff another time. I'll build some of those first, but thanks, Todd, for that really cool use of the capacitive touch. And I'm going to wiggle my camera as I look for the shutter or exposure. Oh, you know what? That was not really in great focus, was it? That's better. Okay, that's nice and sharp. Now it'll be a bit blown out, but oh, not bad. Not too bad. Ooh, So thank you for that, Todd. Super cool. And actually, while I'm over here, I've got another show and tell. And you know what? I'm going to pull up. This was, I have a big piece of EVA foam here, which I don't usually have on my workbench, but I needed to flip over the MIDI Meowsic keyboard to screw it back together, and I didn't want to scratch it up since it's just spray paint, and I didn't put a finisher on the matte side of it. Maybe I need to get some matte sealant for that. That's probably a good idea. But, oh, you know what? That one camera looks like it's pointed a little high. Let's see. I'm just going to back that one out a little. And there we go. And so my other show and tell, actually, I'm going to, before I show this, let me just bring up my camera a bit there so you'll be able to see. And I'm also going to bring up my Discord, so if anyone's got questions, I can see what's going on. Or if my audio goes out, that's the biggest concern. Todd says, Pico Touch Grid is not fully baked yet, but you want to look at the source code, it's up, and he posts a link there. So head on over to our Discord to check that out. So my other thing I wanted to show and tell wise, was this great sidewalk find. I posted this on, I think on my Instagram. I was walking the dog and I saw in the distance a pile of stuff in front of a house that they were getting rid of, and among the stuff, it was a small pile, but the thing that caught my eye was this keyboard. So this is a, oh wow, why did that view just change? That's funny. Huh, something bumped that, I guess. So this is a 1987 sort of toy keyboard, kind of thing you'd find at a Toys R Us back then. from Yamaha. It's the PSS 470. I think these might have been in the $200 range new. And this one is in pretty good shape. Now, it had been raining the morning that I found this, and luckily it was lying kind of like this, so the water didn't pool up too much in there, and it didn't run directly into it. So I got it home, I took it apart, dried everything out, cleaned everything up, took a look at things, and it's in great shape other than this one broken key and one missing slide cap, little slide switch cap here. The thing that makes this interesting, because you'll find a lot of cheap keyboards, for example, the Music keyboard here that I've been playing around with. Music, it's very modern, but what it's got in it is essentially a set of sampled sounds. You can't really change them in any way. You're just going to be playing back things in one of 5 sampled and repitched sounds. A lot of junky keyboards, toy keyboards will be like that, or much older ones will be some sort of like a square wave that has maybe some slight variations on it, but it all is some fairly low-end forms of synthesis or sample playback. This thing, however, is among a set of keyboards that Yamaha put out that use the same FM, frequency modulation, FM synthesis chip, sometimes called the OPL2 chip, that is in the AdLib and Sound Blaster cards from the 90s, 80s and 90s. So basically all the MS-DOS games, those were playing multiple tracks, sometimes I think 9 tracks plus drums can all play on this, this Yamaha chip. I think it's the 3812, YM3812 or YC, I'll have to look it up. But the same chip in here. So it's got, of course, preset sounds, so you can pick those, and these are all FM modulation, frequency modulation synthesis presets. You can modify those with these sliders, or you can go into a mode where you are crafting 2-operator FM synthesis from scratch using these options here. And I won't go deep into FM synthesis, but the short story of it is you usually have a carrier wave, usually a sine wave, which is then modulated by another wave, and changing the frequency ratios of those, the pitches of those, and the way those interact, as well as the attack and decay of those, give you a lot of variety. The thing that FM synthesis is really known for is the DX7 was a keyboard in the 80s and 90s that was used all over the place in pop music. It's a lot of these sort of brassy bell-like sounds, but also some noisier sounds, some lush pads and sort of plucky string kind of sounds. So there's a lot of 80s music that you can get out of FM synthesis, and this thing is one of them. So I don't have it plugged into any external audio. It has an out, actually has a stereo out that could be plugged into something, but I don't have that set up right now. It also has a headphone out, and it's got a, I think, 9 to 12 volt DC center positive jack. I put C batteries in it, so it's running off of 6 C batteries right now. And I'll just give you a demo of a couple of just the sounds, as well as designing your own sounds. These LEDs do not blink in real life, by the way. You'll see them blinking just because of shutter rate, but they're not trying to tell you anything with blinking. They're just telling you where in this matrix you're making your sounds. So let me turn up the main volume a bit. It's got a noisy pot there, so I need to probably go back in and clean all of those. I didn't. It has 9 voice polyphony, so you can play up to 9 sounds, then the 10th one just won't, keys rather, 9 keys. Nothing with my nose there on the 10th one. It can also play some drum sounds that are built onto the chip, and then you lose a couple of notes of polyphony if you add drums in. So this is their cosmic sound. They have a nice sustain on here, which sounds kind of like a reverb. There's also a bit of a chorusing effect going on, which you won't hear because I just have a single mic here. You may, but if you have two ears in your ear, or if you're hearing it over through a stereo mic, it is doing a sort of chorusy pseudo stereo thing. These are mono sounds, but it does this stereo symphonic with. It kind of thickens it up a bit. There's also a vibrato. I think the speed of that is fixed, and I haven't wanted to use that as much. Here's their jazz organ sound. Let's do a brass sound. Horn. So any of those can be modified with these, but I want to go straight to these. So now what we'll hear is just the 2-operator FM with you adjusting what it sounds like. So at first we kind of mostly get this sine wave sound. That's changing the frequency, I believe, of the modulating tone, and it's leaving the carrier alone. Attack is a slow attack when it's at its bottom position, so I just turned that up so you would hear the kind of full sound at the beginning as it modulates that. So you can make it decay really quickly by setting decay up top, or let it have a long tail. And then we can start adding modulation. Some harsh modulation. So it's really cool because this is direct access to a few of the FM parameters that have been set up to sound good together, because FM is famous for being really difficult to craft sounds in, because it can sound terrible for like 80% of the things you change, and then finally you hit a sweet spot. So this is pretty much almost entirely sweet spots. They've given it ratios that sound good of the modulation frequency. It's not if you change those to the wrong numbers on a synth that lets you, they sound horrid. So this has actually got a bunch of stuff going on to make it really quick and easy. I've never seen FM synthesis that lets you so directly and quickly change stuff, which is a lot of fun. I had their very modern remake of the DX7 called the Reface DX. And it was great. It had actually, I think, 4-operator FM, but it was really difficult, even on that simplified thing, to actually design the sounds. So this one's pretty cool in that they've made it really easy to access. What you see is what you get. There's no MIDI input or output. It's got these little mini keys. There are mods out there that people have done to add MIDI. I may consider it. It might be interesting to essentially feed MIDI, or rather feed key presses into the matrix of this keyboard off of something like a KB2040, so that I can send MIDI to the KB2040 and then have it send note presses to this, and then I could sequence it and do other stuff. As you can tell, I'm not a keyboard player, so I just flub around on this, but it would be kind of fun to send it sequences. The other things, like I said, I'm missing a cap. I've got a broken key. So broken key, the options here are 3D print one. I found someone had modeled and posted an F key. I need a C key, and that one is real close. I could model it either from scratch or modifying that and 3D print it. You can buy these replacements from various people online who sell parts. They buy broken keyboards and then sell you for $10 one part at a time. What I opted to do is actually buy like a $25 other keyboard from on eBay from Yamaha of this time period that uses identical mini keys. So I'll have like 32 keys, so I can go break them. And I think that one has a cap that might work here, a slider cap that might work here. So kind of a fun free find. These usually are in the $100 range if you're trying to get them on Reverb or places where people who care about vintagey toy synths. Also, a lot of people like to circuit bend these, and so that's why you don't see them show up cheaply at thrift stores or anything like that anymore. People tend to know what they're worth. But a lot of fun. I'm excited to maybe do a project with feeding MIDI into this thing. I don't think we have any projects like that in Learn Guide of how to take a thing that doesn't want to bring in MIDI and make it bring in MIDI, which would make it a lot of fun to play with. Let me see if anyone has any thoughts or questions, or let's see. Yeah, 9 fingers, too cheap for 10. Yeah, let me jump over to, I'll show you, if you look at the info on this chip, it is like I say, a pretty well-known and beloved, somewhat for nostalgic reasons, Yamaha Sound Blaster chip. So that'll take you to Yamaha OPL wiki. So it's the FM operator type L. That's what the OPL, but it's their FM synthesis chip, all on a single chip. The series has 3 main versions. The one this has is this one here, the OPL2. That may be the one that was the most of were made, because I think that's the bulk of the Sound Blaster and Ad-Lib sound cards had this, which means that people wrote for games like Doom, for example, the soundtrack would be playing back through this chip on your your Sound Blaster compatible card. There were probably other I think those were probably playing MIDI and just expecting a chip that could receive MIDI on 9 channels, or 7 of them and 2 percussion, or whatever it is. But this is the chip that you played a lot of games on in DOS machines, probably, and maybe Windows too. And then there was the OPL3 as well, which has twice as many channels, 18 channels. I'm not sure what this one was used in sound card wise, if it was just like the upper level later versions. Yeah, here's one that was in the Sound Blaster 16, so maybe they named that for being 16-bit in some way. But anyway, that's my exciting sidewalk find, curbside find. And if you're interested in that sort of thing, there are FM synths. Yamaha made a lot of them. Most of the inexpensive ones will be in this PSS, or Portasound S, PSS line. So you can go and look around and see what you find out there that uses this type of method. All right, so that's that. What else have we got? I'll give you a quick reminder that if you want to buy some stuff, you won't be able to find that keyboard in the Adafruit store, but if you want to find some fun stuff to maybe modify something like that, head on over to Adafruit and you can get 10% off in the store on your way out. Just type in umbrella, that's today's coupon code, and that'll get you 10% off on your entire order of stuff. So go, do it, buy some cool stuff. I think that's going to do it. So the Hex keypad is in progress. I think Lamore and I were brainstorming about a coffee-related project that might be upcoming, and I may poke around with this and see if that turns into anything interesting project-wise. Otherwise, I want to thank you all for stopping by. Thanks to everyone over in our chat. I got to check out this GIF because someone who knows how to actually play the keys doing cool stuff there. Thanks, Janisku. Yeah, so nice. It runs on batteries too, which is kind of fun. Not only is it portable, but you don't have to worry about ground loops and things when you're on battery power. Speaking of finding stuff, some nice said that you saw a Sony Trinitron CRT at the recycling center and thought of me. Did you get it? Did you bring it home? I think that's going to do it. Thank you. Hey, thanks, Andy. I appreciate it so much. Thanks over in the YouTube chat. LC37R011. Yes, a sweet find. I'm excited about that one. All right, that's going to do it for today. Thank you, everyone, for stopping by. For Adafruit Industries, I'm John Park. This has been John Park's Workshop, and I will see you next week. Check on our Discord and our blog to see Scott may be streaming tomorrow or Saturday. He was threatening to yesterday, so go and check and see if he is. I believe that Tim is out, so there's no Foamy Guy deep dive tomorrow, but there may be a Scott very, very special broadcast. So stop by, and then other than that, come on back next week for a whole new batch of shows. Thanks, everyone. Bye-bye.
Thank you.